DataSift, which is a local company in Reading, founded 6 or 7 years ago by a guy called Nick Halstead. I've worked there for about 4.5 years. So we're around here, and we've got a big data platform processing social data. And I'm going to talk, I'll talk mainly about social data today and some of the things that we can do in our platform. So that's what you're in for with my talk. Just in case, I'm a data scientist, just in case people don't know what that is, I don't know whether you can read that, but I work in the intersection of these three blobs: hacking, which is coding, maths and stats, and substantive expertise, let's put their domain knowledge. So that's the sort of thing I do every day. I'm using my coding ability and my knowledge of statistics and so on, and also some business domain knowledge, which I've built up over those 4 years working at DataSift, working with our customers, market researchers, brands, those sorts of organizations to use those skills to answer business questions in those domains. So I'm sort of mixing and matching all these different things. That's what I do with my team. Here's the agenda for today. First of all, I'd like to talk a bit about the expanding digital universe that we're sort of surrounded by. A bit then about the evolution of social data as we see it. Something about how we think you can do social data analytics. There are a few challenges to get through. And then focus a bit on privacy by design. So we're quite proud of the fact that we have a platform which respects people's privacy on non-public networks, as I'll call them, and that's something which is right at the hub of the design of our platform. We think that's very powerful today, and then I'll go on to show you some examples of how you can sort of deploy and use this sort of technology. So the expanding digital universe. You can't see it very well there, but I've got a big picture here of the Big Bang, and this is the expanding physical universe. And the digital universe is expanding too today. There are lots of different types, a mind-boggling array of different types of data which we produce as a society. We've got things like social data. I'm going to talk mostly about that today. There's lots of data about people's behavior, how they behave on entertainment platforms, the sort of entertainment, the sort of music or the sort of TV that people like to view, how they behave just clicking on links or typing stuff into search boxes on the internet. There's data about people's employment histories and their skill endorsements in networks like LinkedIn. There's all the data being produced by wearable technology, Fitbit, etc. You can measure your blood pressure, your heart rate, and all sorts of other biometric indicators these days on these devices. And there are, electronic medical health records which are stored, which track people's physical and mental health across their whole lifetimes. There's a mind-boggling array of all this sort of data out there, and there's more and more of it. And it's a fascinating field to be in, and there's a lot of potential there for science and business. Now, it's not easy, of course, to actualize all of this potential. There are a lot of challenges to face up to, and I'm going to focus back in from that sort of expanding digital universe back into social and talk about that. And I think you can't really see it here on the picture, but it's also interesting, it's also humbling to remember that our expanding human data universe, it really is just occurring in this very small planet there in that very small galaxy in this much bigger expanding digital universe. But nonetheless, it's a very interesting field to be in. So I wanted first to give you a sort of, just for context, a bit of a sort of framework of the different types of social network that we see out there today. Public networks, walled gardens, one-to-one networks, and image-based networks. So I'll just step through these. I'm going to focus in on the walled garden network for most of the latter part of my talk. Public networks, so think of Twitter, something like that, or Facebook pages, public pages. This is where brands and consumers commonly engage directly. So, people they enter into dialogue directly with brands, or they self-promote what they're about, those sorts of things. A very explicit, sort of open platform to express yourself or to converse, criticize your brand, or interact with a provider on their customer service channel, those sorts of things. And it's typically, this is a place where a lot of social analytics is happening today. There's a lot of analytics happening on Twitter. And it's a very interesting place. There's a lot of useful, valuable data to analyze there and to apply. There are also these walled gardens. This is Facebook, for example, where you share intimate details with your friends, your family, and your colleagues. So this is typically a place where people are, really interacting with their loved ones, and it's a more intimate sort of network to hang out in, and it's a very interesting place because people are expressing their sort of aspirations, their opinions. They express their attitudes towards brands in a subtler sort of way, and it's very interesting because this is where most of the activity happens. A huge amount happening in these walled gardens compared to public networks, for example. Then there's these one-to-one networks. Snapchat, for example. Think about that one. This is where people typically engage one-to-one or one in a very small group. Sort of ephemeral sort of conversation breaks out and collapses. Typically that's sort of considered off limits to social analytics and brands and so on right now. And then there's image-based networks, such as Instagram, where people share images and love to share the way they, the images they take and the way they process them, the way they organize them and so on. This is typically a very difficult place or has been a difficult place to analyze because it's all in images and it's tricky to analyze images. There have been some huge breakthroughs in the last few years in analyzing images. So that's sort of a ripe sort of network for analytics to kick off, and we'll see how that evolves. They have really, in Facebook, for example, invested a lot of money in machine vision, computer vision, and there have been some huge advances recently using deep neural networks and so on to interpret images. There's a very nice example recently which Facebook broadcast about machines being able to describe images to blind people. So, this is a really interesting use of that sort of technology to help blind people read their Facebook feed and other types of images. They don't need to be able to see them. The computer will just describe to them the image that it reads for them. So, lots of different types of networks: public, walled garden, one-on-one, image-based. And there's a lot of people on these sorts of networks. These are just the latest Facebook figures, which I'm putting up here. 1.65 billion people a month in the walled garden Facebook. 1 billion people in WhatsApp. 900 million in Messenger. 400 million in Instagram. So this is a huge place. A lot of people. A big part of the planet is sort of hanging out in these places and communicating with their friends and expressing themselves there. So social data analytics then. So clearly there's a lot of data out there. It's a fascinating place to be. There's lots of value for science and business. I'm going to focus on business applications here. These are some of the business applications that we commonly see at DataSift. These are the sort of things that our customers are doing. So they're doing brand analytics. So they're interested in measuring the reputation of the brand or how the brand stacks up against other brands. They're interested in doing content and media analysis. What sort of content is driving most engagement? External content produced off network, coming into the social network, creating engagement. Very broad studies, industry level studies. What's happening in the movie industry, for example. Those sorts of things, or indeed studying a particular audience. What excites a specific audience, how to reach out and engage that audience, and potentially, make that audience, take some of that audience and make them customers. Those are the sorts of business applications that businesses are chiefly interested in, I think. Those are the ones that we see at DataSift. And then, so here are some of the challenges then. In putting this data to work, there are some technical challenges due to the sort of intrinsic properties of the data. It's very high volume, very high velocity. There are 2.1 billion people, I think I've got down there, interacting on these social networks. That's a lot of data. And it arrives very, very fast in the systems that need to manage and analyze it. So inside DataSif, I think we process around about 1 million messages a minute, or something like that. So it comes in very thick and fast, and you need it's an engineering challenge to engineer a platform that can gulp down that amount of data, filter it into relevant parts and throw away irrelevant parts, do some sort of analysis, make it into something interpretable and usable and applicable to a business question. So that's the volume and the velocity. There are lots of other V's that people often talk about. The one I'm going to talk about here is the structural properties of the data, which is natural language. That's not a V, but variety is one of the other V's that people often talk about. Natural language. So, people express themselves in English or French, whatever your mother tongue is. That's how they express themselves on social networks. And it's a very challenging computer science problem to get a machine to read natural language and interpret it, make sense of it. So that's a computer science challenge then in this field. And then there's a different type of problem, which is really to do with the provenance of the data rather than the structural properties of it. It's where it's coming from. It's coming from you and me, your families, your friends. These are the people. It's coming from people, and typically people share this data with their friends and their family, and it's difficult sometimes in these walled gardens to figure out how you can put this data to use to get some business value out of it, whilst respecting people's privacy. And that's, we think we have a solution for that, which we call Pylon, and I'll talk about that as we go through the talk. But that's one of the key challenges today, I think. How can you use the data whilst respecting people's privacy? So the first example I've got here is, it's an example to try to illustrate the difficulty of working with natural language. So here's an example analytics project. And this was a simple project run last year by the Bank of England on Twitter data in the run-up to the Scottish independence referendum. They were interested in measuring the temperature of the market, looking out for instability in the markets. And so they built a tracker which tracked what people were tweeting about around financial institutions and using words which might indicate lack of confidence in the market and so on. And so this is a chart of one of the signals they saw in the run-up to the Scottish independence referendum. So a few days before, they saw this big spike, and their tracker was labeling the output with the financial institution which was detected and the type of confidence signal which was detected. And this spike here was labeled with RBS and run. So the question is, so superficially that could look like a signal, or signalling a run on RBS, on the Royal Bank of Scotland. And in fact, of course, it was nothing of the sort. This was just a signal picked up around an American football match. You can't really see that very well, but this is a guy called Adrian Peterson, who's a running back for the Minnesota. I can't remember the name now. Minnesota Vikings, something like that. So he's a running back, and in the States, people abbreviate running backs as RBS, running backs. And they often talk about them running around, obviously. So this is the sort of thing, these are the sorts of issues that you can bump into. You can, in very good faith, you can invest a lot of time into building a tracker. You put all your keywords in to pick up the signal you're interested in, and you can bang into these huge false positives like this. So it really is an issue. And as a data scientist, I spend a lot of time in the data mines trying to write, simple conditions which pick up true signal and leave these irrelevant signals to one side. So this is all about ambiguity in natural language. And here I've got a few sort of terms and hashtags that you may see inside Twitter, and I've got the nodes represent terms and the edges represent sort of similar sense. This is, two nodes are connected when they could be used one for the other. They could be substituted. One term could be substituted for the other. And this is the sort of structure you've got around RBS in the middle. You can see that on the left, there's hashtag RBS connected to a bunch of banks, financial institutions, and RBS on the right connected to running backs and a bunch of other terms inside, related to American football. And And then there's another aspect, which is synonymity. So often you find that two words can mean the same thing, rather than one word meaning many things. And this is also an issue. If you wanted to write, if you were not the Bank of England, but you were some sports brand and you wanted to find out what was happening, in fact, inside the National Football League, in order that you could figure out, which was the best team to sponsor or which was an upcoming player that you might like to sponsor, then you'd like to track the whole of the NFL. What's being discussed? What's the conversation around NFL? It's not as easy as tracking for hashtag NFL. A lot of people talk about the National Football League using all these other terms. And that's very painful if you're trying to write a tracker which picks up NFL, because you need to somehow source all these terms and somehow write some sort of query which unifies them and finds a relevant data set. So, these are painful problems that result in a lot of human labour. And I just wanted to give you the flavour of some of the sort of technology, which is recent technology, again developed around neural network theory, which sort of can help can help you as a data scientist in your endeavour to do this sort of filtering on topic. And it's a technology called word Tyvek, which is sort of relatively sophisticated piece of technology, but I'll try to give you the flavour of it. The idea is that you give, instead of taking a lot of data scientists' brain cycles and getting them to source all of these various words that might together coalesce to capture the concept of NFL, what you do is you feed a huge corpus of text, billions of tweets or hundreds of millions of news articles. You feed that into a neural network, into a machine essentially, which gulps it down and learns the meaning of words. There's a training algorithm which can run, and when this thing runs and finishes, what you'll have a representation of each word that is seen as a sort of set of numbers, a vector. That's why it's called word Tyvek. It's a list. Each vector is a list of numbers. So it's a way of mapping words into this abstract mathematical space, and it has some very nice properties in that you can sort of do arithmetic with the vectors afterwards, and that seems to correspond remarkably to some of the semantic relationships that words have. So, for example, you can take the vector for king and the vector for man, and you can subtract one from the other, and that would give you something like, a monarch or something like that. And that's also equal to the vector queen minus woman, and you can do these sorts of things. It is quite cool. And then what you do as a data scientist is you switch, instead of working with words, you sort of switch and work inside this vector space. So instead of writing your filters in terms of words, you write them in terms of these vectors. Now let me see if I can get that. Oh, so yes, it's working. So here's a good example of you can try this for yourself. This is a public URL, and this is one of these word Tyvek models built on top of the entire Reddit corpus. So this machine has sort of gulped down and crunched the entire Reddit corpus, and it now knows what NFL. It sort of knows which words are similar to NFL. So NFL. There are some interesting normalization issues here. There's a point at the end here. Patriots, NFL with a space.
Jim,
yeah.
in the way that's
Oh my goodness.
even better.
Sorry. Excuse me for that. So let me go back to the top. So if you type NFL in here, you get the sort of synonyms essentially. Synonyms for NFL. You can type other stuff in here. One I liked earlier was amazeballs. That was quite nice. It's quite an oops. Oh dear. Typing. That's cool. Amaze. So these, typically on social networks like Twitter, you get a lot of slang, and you like to know what these things mean. So it knows that amazeballs means amazing, awesome, fantastic, awesome, love, and all these sorts of things. So it learns all that sort of stuff. So you don't have to do it yourself as a data scientist. So that's one piece of technology that can help you do this help you tackle this challenge of natural language. Right. Let me get on with the next section. Okay, so let's get back into privacy by design now. So, before we sort of learned that, or we didn't learn, I just sort of rehearsed the fact that there are these walled garden, non-public spaces where a lot of people are active. And we would like to be able to use the data in these spaces to help us answer business problems or to, just to use in our business. So the question is, how can we do this? So I've tried to put the question here: how can information useful to business be extracted from non-public spaces while wholeheartedly respecting people's privacy? Now, so we have a solution to that, and we call it Pylon. And I'll give you a quick conceptual introduction to it, then I'll show you a little bit about the architecture and then show you an example, and that will be the end of the talk. But so the way this works is you have to make a sort of switch inside these non-public spaces. Do not think in terms of individual people. Think in terms of audiences and demographics. So think about groups of people. What this solution gives you is it'll find patterns which play out across groups of people, rather than looking at what individual people say, the verbatim, posts that individual people say or express. Now so that's the basic idea here. So just to illustrate that, on the left I've got am I standing in the way again? On the left I've got a crowd of people on Henman Hill at Wimbledon. That's the underlying reality of the thing. Lots of people, different shapes and sizes, different ages and so on, and they're all supporting and cheering on their favourite players, Roger Federer and Novak Djokovic. That's what's really happening. In this sort of other view, this more abstract view, what you would do is you'd think about that as an audience which consists of the Federer supporters on the top, the Djokovic supporters on the bottom. On the left you have, so this is like a demographic and age gender pyramid. You'll have you can see there are different shapes. So Djokovic has got a different there's a different profile for the people that support him. It's sort of skewed towards younger males, whereas Federer is more women in this 35-44 age group. This is fictional data, just to illustrate the point. So instead of thinking about the individuals and what they're saying exactly, think about this sort of abstraction. And similarly, in order to respect people's privacy, don't think in terms of what the people actually say, think in terms of topics and attitudes. So what you need, in order for this to work, you need good support in your platform, in your natural language processing, which can stick topics and attitudes on the text that's flowing through the system. So when someone talks about a BMW having a sumptuous interior, you need your platform to put BMW label on it and they're talking about comfort here. It's got a comfort feature. So you need a platform which can do that sort of stuff. So Pylon operates in the context right now of Facebook topic data, and it's actually running inside the Facebook network. So we have a partnership with Facebook. We run this inside their network. Facebook already identifies lots of topics. So it's got a great natural language processing system, a machine learning sort of system which can label text as topics, and these topics correspond to public pages. And you can see here then, these are people milling around at the Detroit Motor Show. They're all talking about the cars. That's the underlying reality. In the Pylon way of thinking about things, you think about this sort of distribution of people talking about various brands having various features. You've got down here practicality, a mechanical specification, style, performance, running cost, safety, those sorts of things. So you go up a level. And these facts aren't individual people talking about very specific, explicit phrases and sentences, but it is very useful nonetheless, this sort of information to marketers and brands. They can see the different fingerprints that all these brands have in the eyes of their audience on Facebook, a huge audience. Now this is how Pylon works. As I said, it's running inside Facebook. It receives the news feed from Facebook, which has been anonymized. All personally identifiable information has been stripped from it before our system sees it. But then all of the raw text and so on goes inside our platform and allows you as an external customer to filter it and to ask various questions of it. So it runs inside Facebook. It gets to see all of the raw text, but you as a user, you use an API in our system to ask. You can ask very explicit questions, but you only ever get anonymized, aggregated results. So things like the sort of histogram that I showed you before. Okay, so I think I'll skip this. So there's a lot of different dimensions on the data. You've got various topics, demographics, sentiment analysis. You've got various links, all of those sorts of things, different types of engagements, and so on. I've got a couple of examples here. So we run behind it. We expose an API. We're a platform. We don't sell a product which has a front end that people use to work with this. We partner with application builders who build on top of this. So we expose an API. And if you want to then, so this is an example of how you might, as an application builder, interact with our system. You would call our API. You would ask us to analyze a particular data set. We'd pass that into the Pylon system behind the Facebook firewall. The results would come back as JSON. This is a way of describing results in a nice machine and human readable way. And then your application could transform it and display it somehow. And I've got an example here, although I don't know if I have enough time. Have I got a couple more minutes, or am I? Yeah. So I've sort of played the role here of an application builder. I've got a simple script which does all this sort of stuff, which queries the API, gets the results, formats it in a form which is readable by a visualization tool called Tableau, which I don't know if anyone is familiar with that, but it's a rather nice visualization tool which we use quite a lot. To draw graphs and to drill into data. So I just wanted to show you here the sort of results that you can get out of a system like that. Remember, this is data coming out of a non-public network, social network, using this approach of anonymized aggregation for analysis. So you can see things like time series. You can see the sort of topics that are detected by Facebook. You've got all of the car brands here, for example, various hashtags, the various links that are being engaged with. I'll just skim over a few of these. You can see these different types which are available, to break down the data, whether it's generated by a page, which is tiny in this case. You can see here that most of the activity is user-generated activity, something you wouldn't normally see unless you use this sort of system. The different types, comments, likes, reshares, and so on. There's a sort of share of voice visualization here. We compare BMW, Honda, Ford, and then there's a sort of demographic breakdown as well, which is probably a little difficult to read, but you can see where the volumes are coming across the US and the sort of age-gender pyramid for that. So that's that's how the solution works. It gets access to all of the raw text behind the firewall. And it enforces very strict privacy constraints, which mean that although it can analyze some of the raw text, only aggregated, anonymized results come out. So it's sort of privacy safe from that point of view. You never find out what an individual is saying, but you can find out what groups of people are saying. And if you want to be scientific about it, it's good to know that that your sort of the results you're pulling out have statistical grounding. Right, let me go back then to this guy here. And so this is one other example of this is just a silly moving GIF which you can't really get. But this is another example. So we worked with a company which was producing TV program. There's another example of how you can actually use this. And they were very interested. This is a quite popular TV program. They were interested in finding out how people viewed various actors that they were using in their TV programs, the sorts of themes that excited them the most and others which fell flat, and which sort of demographics, which sort of actors and themes resonated with which sort of demographic. And using the sort of data that we were able to pull in this way, they were able to guide their scene creation, to decide which breakthrough actors to keep, which ones to not keep, and how to promote their TV program to target it to the right sort of demographics, to get the best to get the best uplift really on their advertising spend. So that's another example. This is a real example that we've done recently. And so that just shows you then how we use Pylon to navigate this this issue of privacy. So we respect it at the core. It's an absolute in the system. Nonetheless, you can still get out interesting insights to power your business decisions. So I've sort of come back full circle here, really. Then, and I really just in summary, then I've just explained that we've got a lot of people on these social networks. There are some challenges to using the social data they're creating for business, but there are some interesting solutions which help you do this in terms of natural languages, using neural network theories, and also in terms of privacy, using this approach of anonymization and aggregation. And I think that's me done.
Time for a couple of quick questions, then we'll have a break for drink if anybody has any questions, any specific questions.
Are we going to vote leave or remain?
Oh my goodness. Yeah, well, I haven't, yeah. Good question. Yeah, that's the sort of thing that you could potentially, of course, study on in these sorts of, you could ask the audience on Facebook, I guess. It's a difficult question, of course, to turn that into.
Have a little look under the hood.
I haven't, no, I'm afraid not. No. It's not easy to formulate those sorts of questions, but of course there'll be a lot of people trying that sort of stuff, yeah. Ooh. So, yeah, okay. Who's choosing? Are you choosing? Or am I
Drew. Yeah, hi. I was wondering how you make use of the network side of social networks rather than the properties of the individual and aggregating those. How do you make use of the interactions and networks of those people with other people?
Yeah, that's more difficult to do, obviously, because you sort of have to abstract away from the individual. So that's more difficult to do, and that's the price you pay, if you like, for getting access to this huge audience, that you can't do those sorts of things. So that sort of influencer analysis is difficult to do at the individual level. You can still do it at a high level of, if you're interested in celebrity influencers, it's possible, because typically, if there's big celebrities or big influencing organizations will have Facebook pages, and they appear as topics. Typically actors, the sort of actors, directors, public figures all appear, and so you can see when people talk about those people, they get labelled automatically as topics. You can see it that way, and you can see which sort of media channels are influential. But in terms of individual people, that's not visible. Again, to protect the individuality of those people. Yeah. So yeah. Hi.
Hi. Your data is anonymized when it comes out of Facebook, but how many dimensions do you need in able to effectively regather someone's identity? Because it seems to me that if you filter your demographics down far enough, you will end up with one person at the end of it. You might not know their name, but you already know lots of information. Yeah,
no, good point. Yeah, so there are lots of. That's a very good point, and the way we protect against that, so that's a sort of attack, if you like, on the sort of, so we're trying to build in privacy protection there, and that's a sort of an attempt to attack the system. Thanks. No.
I'm not saying you do, I'm saying you could.
Exactly.
If you could, then if I know that you can, then why would I trust a data analytics company?
I do see, yeah. So we have it. So the way we protect against that is by stopping you drill in. So you can only drill in so far. Yeah. So we make sure that there's a sort of level of coarse graining. So you can't drill into it. You can't drill it down into a group of one. You have and there are various settings that you can choose. So take 100. So imagine you can only drill into a group of 100 people. It becomes exceedingly difficult then to run that sort of approach. So and because the audiences are large on Facebook, it's okay to do that sort of stuff, because even if you keep that granularity, that coarse graining at 100, you can still read out interesting statistics, but you never get down to these very micro little audiences. That's the approach we take.
Yeah, that's fair enough. I guess the worry is that, okay, I guess that makes sense. But it seems if you know how it works, then I can see why people would have a problem with that. If you sort of mean, just what I'm saying, you've got a trust issue to surmount.
Well, I think that's true of a social network in general. Yeah,
sure.
Yeah. So we're sort of, if you like, we're running as part of the Facebook network here, and so I don't think we're not contributing, we're not weakening the system in any way. Yeah.
Time for one more.
Hi. Sorry.
There's been a lot of talk in the media recently about Facebook and people posting less personal information on there. Does that impact what you're doing?
Well, I think yeah. So, I think the less personal information. I don't know. I'm not sure of that story. Maybe the story I've heard is that because people's timelines are getting very, very full, there's a lot more competition for real estate on your Facebook page, and so there's more competition then amongst brands to get something which is interesting in front of a potential a target, as it were. And so I think these sorts of analytics can help, because you can figure out what sort of content works, is engaging, and you can also figure out which is the best group to target your content to, so that you're not targeting. No one wants to target stuff to people that don't want to read it. That's just annoying for everyone, and so it helps you sort of do more precision targeting. You can get better. You can be on target and sort of on message and on target. That's the idea behind that. But I'm not sure that connects exactly with your story.
Okay, thank you, Tim. Thank you.
Thank you.